11.2 is probability. And when we talk about probability, I want you to understand that it's always part over total. Probability is part over total. Now, sometimes it's simple problems. Sometimes it's more complicated problems. But when we're talking about probability, we are always talking about part over total. So it's going to be a fraction. Number 1 says a shipment of 7 smartphones contains 3 with cracked screens. If sold in random order, what is the probability that the first 4 have undamaged screens? Okay, so I think a good strategy is to really focus in on what they're asking you. What is the probability that the first 4 sold have undamaged screens? And so if we really try to nail it down, we look at this and there are 1, 2, 3, 4, 5, 6, 7. Sometimes I think it helps to draw a little picture. So we've got 7 smartphones and 3 of them are cracked. And I don't really know which 3, but 3 of those are cracked, right? It's not going to be as simple as just saying 3 out of 7. All right. I wish it was that simple, but it's not that simple. All right. Or 4 out of 7, right? Okay, because we're going to have to do a like a group from a group kind of deal. So we want, think about what we just underlined. All right, the first 4 sold have undamaged screens. So when we talk about part over total, the part is what we're looking for. All right, and specifically what we're looking for is 4 of them have undamaged screens. Okay, so there's only 4 with undamaged screens. And so if I'm trying to pick out the 4 with undamaged screens, there's only one way of doing this. So when this is going to be part over total, there's only going to be one way of picking 4 undamaged screens. Now, I suppose you could say out of the 4, we're going to choose 4. In order doesn't matter, so you could say 4C4, but 4C4 is equal to 1. 4C4 is equal to 1. So there's only one way of doing it. So now the total is the denominator. And the total, if you think about it, we have 7 smartphones and we're taking 4 of them. All right, so out of the 1, 2, 3, 4, 5, 6, 7, just think about it as how many ways are there of picking any 4 out of those 7? Well, any 4 out of those 7 might include cracked screens. All right, and so all we have to do is say, well, 7, choose 4, because order doesn't matter. It doesn't matter if I pick a cracked one first or a cracked one last. It doesn't matter. Right? But that's how many total ways of picking 4 out of 7. So 7 choose 4 is 35. So this part over total fraction becomes 1 over 35. And I think fractions are a little bit harder to understand than decimals. So I would probably convert it to a decimal and give me about 4 decimal places. I think that's going to be good. So let's call this 0.0286. I say usually 4 decimals is good for me. All right, so all of these problems are some kind of version of that. Let's look at another one. A gambler places a bet on a horse. To win, he must pick the top 3 finishers in order. So notice those words, in order. 12 horses of equal ability are entered in the race. Assuming the horses finish in a random order, what is the probability the gambler will win his bet? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's say that's the order that they finish in. And we're talking about the top 3. So we want to look at the way he's picking the top 3 finishers out of 12. So probability is going to be part over total. And again, there's only one way. It won't always be just 1 on the top, by the way. But in this case, there's only one way of picking the 3 top finishers in order. But there are a lot of ways of picking any 3 horses in order. And so the bottom of this fraction is we've got to pick 3 out of 12 and put them in order. All right, so it's a group out of a group, 3 out of 12, and order matters, which makes it a permutation this time, not a combination. So 12p3 is 1320. That means this fraction is 1 over 1320. 1 over 1320 is about 0.000. I think maybe 5 decimal places would be more descriptive this time. So it'd be 0.0008 if we were rounding to 4. Let's call it 76. Doesn't really matter, I don't think, but I think 5 is a little bit more descriptive than 4. Okay. So you can kind of see how this is going. Number 5, there are 11 songs on your playlist. With random shuffle and no repetition, you listen to 2 songs. What's the probability that you listen to your favorite song first and your least favorite song second? Okay. So let's say you've got your favorite song and then your least favorite song, and then there must be 9 more songs. So let's call it song 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 total songs. And you listen to your first one or your favorite one first and your least favorite one second. So again, there's only one way of doing that. All right, you've got your favorite song, you've got your least favorite song. How many ways are there of doing this? Well, there's only one. But then the bottom is how many ways of listening to the songs. Okay. So you're only listening to 2 songs out of 11. All right. So it's a group from a group, 2 out of 11. And so you're thinking about, does the order matter or not? Order matters. Your favorite, your least favorite. Yeah, you definitely think about order matters. So that's going to be 11p2 right there. One over 110. 0091. All right, so far so good. Let's kick it up a notch. All right, it's fine. Once you see a couple, it'll be fine. There are 14 songs on your playlist. 8 of them are country and 6 are pop. With random shuffle and no repetition, you listen to 8 songs. What's the probability you listen to exactly 5 country songs? Okay, so let's think about this. You've got 1, 2, 3, 4, 5, 6, 7, 8 country, and 1, 2, 3, 4, 5, 6 pop. So we've got 14 songs. That's what that is, 14 songs. 8 are country and 6 are pop. It says with random shuffle and no repetition, you listen to 8 songs. What's the probability you listen to exactly 5 country songs? So you have to kind of focus on what they want, what they ask, because what they ask in that question is going to be the numerator. So if we want exactly 5 country songs, I don't know that order matters. We're just going to take any 5 of these. You know, maybe we've got these 5. All right. So can you feel how we're taking 5 out of the 8 country songs? I'm feeling a group out of a group right here. We're taking 5 out of the 8, okay? But don't forget, we have to listen to 8 songs. So when they say 5 country, there's an implication that we would also have how many pop songs? There must be 3, and I don't know which 3. Maybe it's these 3, okay? But the implication here, when they say 5 country, we're also listening to 3 pop songs. And that's tough for some people to get because they don't ever say 3 pop songs. That's just implied in the problem. But 5 country and 3 pop songs in order to get to the 8 songs. All right. So the numerator is talking about 5 countries and 3 pop songs. All right. But it's 5 countries out of the 8 countries. And order doesn't matter. That is going to be a combination. There are 8 country songs, and we're going to pick 5 of them. And a lot of times in math class, and means times. All right. And is going to mean times here. We want 3 pop songs out of the 6 pop songs, so order doesn't matter. It's going to be 6 choose 3 right there. So that's the numerator of my fraction. I want 5 country songs out of the 8, and I want 3 pop songs out of the 6. Now, the denominator is usually the easier part because all you have to do is look at the total. How many total songs do I want? 8 out of how many total songs are there? 14. That's going to be 14 choose 8 on the bottom. Alrighty. So 8 choose 5. Oops. And 6 choose 3. That's going to be 56 times 20 over 14 choose 8. 3003. So 56 times 20, 1120 over 3003. You can do this. This problem, I know this is new to you, but they're all very similar to this problem. 0.3730. Okay? So just think about pretty much all of the questions are some variation of this. It always goes back to part over total, though. Okay? So number 9, you're dealt 5 cards from a standard shuffled deck of playing cards. Note that a standard deck has 52 cards, and 4 of those are kings. Okay? So it helps if you know about playing cards here. What is the probability that you'll have exactly 2 kings in your hand? So if you think about playing cards, and I deal you 5 cards, and you have 2 kings, there's an implication that you have 3 other cards. 3 other cards that are not kings, right? So I don't know what they are. Maybe it's a jack, and maybe it's a 2, and it's a 4. Okay, whatever. It doesn't really matter what the other 3 cards are for this problem. They're just saying 2 kings. So we've got 2 kings there. All right. So let's look at this as part over total. We want 2 kings and 3 other. You can put non-kings if you want. But that's what we're looking for in this problem. That's going to be the numerator of this problem. It's part over total, and that's going to be the part on the top. Okay? So we want 2 kings out of how many kings? 4. Does the order of your kings matter? Doesn't matter. So that's going to be 4 choose 2. Now, and means times. We also want 3 other cards. So not 52, because the 52 includes the 4 kings. You got to take the kings out of there. How many other non-king cards are there? There are 48 other cards that aren't kings. So out of those 48, we're going to choose 3 of them. Any 3, it doesn't matter. That's your numerator. Okay? All of these problems are kind of similar. Now your bottom is the total. So how many total cards do we want? 5 out of how many total cards are there? Okay. So try that real quick. Oh, okay, I see. 4 choose 2. What's 4 choose 2? I believe that's 6. Sometimes you just you've seen some a lot. 48 choose 3. Okay. And 52 choose 5. 259 8960. I don't know. I was close. Was I right? 259 8960. You see that number kind of a lot. 259 896. Okay. 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 I've seen that problem kind of a lot. I mean, anytime you talk about poker questions and 5-card, a 5-card poker game, that's the number of ways of dealing out 5 cards. All right. So 6 times 17,296. That's your numerator. Over 259 8960. Too much chatter. Keep it down. So we're getting about 0.0399. All right. $11. A shipment of 16 smartphones contains 9 with cracked screens. If sold in a random order, what's the probability that exactly 5 of the first 9 have cracked screens? Okay. So 5 of 9 have cracked screens. So let's see. So we've got 16 smartphones and we're selling 9. All right. So the denominator is definitely going to be 16 choose 9. You can kind of see that right now because that's total. That's the total. But the numerator is what we are looking for specifically. And what we are looking for specifically is exactly 5 of them are cracked. So when they say 5 are cracked, there's an implication. If 5 of them are cracked, what does that imply? How many are not? That means 4 are not. And 4 not cracked. 4 good ones, 4, yeah. So we've got 5. Okay. What other ones? The 5 that are cracked? Okay. Right. Okay. We want 5 cracked ones out of how many cracked ones? No. We want 5 cracked out of 9 cracked. So that's 9 choose 5 to get the cracked. All right. So now we want 4 that are not cracked out of how many that are not cracked? You already said it. There are 7 that aren't cracked, and we're picking 4 out of those 7. All right. If you think about it, it makes perfect sense. 9 of those things are cracked. We're getting 5 of them. I don't know which 5. And also 7 are not cracked. I'm getting 4 of them. I don't know which 4. All right. So you can actually multiply all this out. 9 choose 5 times 7 choose 4 divided by 16 choose 9. 0.3855. I think that problem is a good problem to show you, what's happening. It's kind of the same thing every time. 13. Meeting takes place between a diplomat and 15 government officials. However, 9 of the officials are spies. If the diplomat gives secret information to 8 of the attendees, what is the probability that the diplomat gave secret information to exactly 5 spies? Whew, there's a lot going on there, right? Okay. So 15 government officials, all right? And so when it says 9 of them are spies, there's an implication that 6 of them are not. So that's kind of something you would need to think about. 15 government officials, 9 spies, 6 are not. So he gives secret information to 8 of the attendees. Okay. So giving it out to 8, we can already tell the denominator of this is going to be 15 choose 8. Okay. 15 choose 8. So there are 15 government officials total, and he gave out information to 8 total. That's the denominator. That's the total. So the numerator is going to be exactly what we're talking about in this problem. So when it says, what's the probability that the diplomat gave secret information to exactly 5 spies? Okay. Remember, he gave out information to 8 people. So 5 spies implies 3 non-spies. Exactly. Okay. That's yeah, that's really corrupt. But that's what we're looking for. Okay? That's our numerator. So 5 spies out of how many spies? 9. And order doesn't matter, so that's going to be 9 choose 5. And 3 non-spies out of how many non-spies? So 6 choose 3 right there. And so that's going to be our answer. We can type all of that in. .3916.